Hey guys, how you doing? I just wanted to go over the problem that I was doing in class today that I just wanted to do it better. Okay, basically. So let's take a look right here. So we're doing right here. This is the problem that we did today. Everyone knows this is a confidence interval for the slope, by the way. Everyone knows that cars and trucks lose value the more they are driven. Can we predict the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? A random sample of 16 used Ford F-150 Super Crew 4x4s was selected from among those listed for sale on Autotrader.com. The number of miles driven and the price in dollars were recorded for each of the trucks. Here are the data. Here's some computer output from the least square regression analysis of the data. Construct and interpret a 90% confidence interval for the slope of the population regression line. Okay. So one thing that's important, and it's good, they gave you a graph right here. This is good. It's always good if you don't have a graph, you can always just quickly draw an X and Y axis. So I can tell right here that we have miles driven as compared to right here price in dollars. Okay, we do know that, and that's what we're talking about right here. So miles driven is the X, price is right here, they're going to be the Y. All right, awesome. Let's go and do it. Okay, state. So this is a confidence interval, and this right here, it says they want us to do a 90% confidence interval. So let's say 90% confidence interval, CI, for the slope, the population slope, which is B sub I. And we're going to say right here, it's the slope of the population regression, the slope of the population regression line. And this right here is relating X equals miles driven. I guess I don't need to come here. X equals miles driven to Y equals price in dollars of a used Ford F-150 for sale. Sorry, of used Ford F-150 Ford F-150s for sale. Okay, I don't think you need to have the rest of it. The book, remember, if the book it said at Autotrader.com. I think this is fine. Okay, now for plan, remember what I said in class is that on the AP exam, from what the book it claims is that the conditions, they're going to say a lot on a lot of these, they said almost all these problems is assume all the conditions are met. So all we're going to say right here is what type of interval we're doing, and this is a T interval. Remember, it's T. Don't make the mistake I did in class and do a Z interval by accident. We're talking about a T interval for the slope. All right, awesome. And we're going to just say that all conditions have been met. Okay, Okay, so we're doing a confidence interval, right? And so just remember, a confidence interval is the statistic plus or minus the margin of error, remember? Okay, for a confidence interval, we have like this actual statistic, and we have this is the margin of error to the right, and this is the margin of error right here to the left, right? All right, so to get the margin of error specifically, it's the critical value, which in our case is going to be T star, times right here, the standard error of the slope, okay? So it's the actual statistic, and in our case, actually, the actual statistic is just going to be the value of the actual slope that we're given. So in our case, the actual statistic is going to be our little b sub 1 right here. So what we want to do is we look right into our Minitab table, right? Actually, let's keep it on orange. That's fine. All right, so this right here is b sub 1. Above it, what I'm going to highlight in yellow, that's going to be b sub 0. Now, right here, the standard error of the slope, b sub 1, is right there. This is what we need right here. This is the standard error of the slope. So we know the slope is right there, underneath the constant, underneath miles driven. The standard error is right there. Okay? Now, the only thing, remember, this t right here is not the same as t star. So the only thing we have to actually calculate ourselves is t star. Everything else will be okay. So let's fill in what we have so far. We know the standard error of the slope, as I just circle over there, is 0.03096. Okay, t star we'll figure out in a second. And b sub 1 is the actual slope, and that's right there what I highlighted in orange. Sorry, you can hardly see it. It's right there. It's negative 0.16292. Okay, awesome. So all I need to do is get t star. So remember right here, we are doing a 90% confidence interval. So if it is a 90% confidence interval, get t star, remember. This right here represents 90%. So remaining what I have is the 10% divided by 2. So 0.05 right here, 0.05 right here. All right, so this is a t interval. Very important, okay? Don't mess that up like I did in class right here. So we're going to say right here, inverse t, okay? And when you do inverse t on the calculator, it's just going to ask for the area, and it's going to ask for the degrees of freedom. So one other thing about this is that the degrees of freedom for a regression, right, for linear regression, is going to be n minus 2. All right, so no problem. So our n right here is how many values we have here. So there's our n value is actually 16, if you see right here. So the degrees of freedom is going to be 16 minus 2, which is 14. No problem. So the area right here is 0.05. The degrees of freedom is 14. All right, so let's do that. Okay, so we're going to go and say second distribution, inverse t is, there we are. All right, so 0.05 is the area. Degrees of freedom is 14. Now remember, this goes from left to right, so it'll actually give me a negative, but for t star or z star, we always make it positive, right? So it's going to be 1.76. All right, so there we go. Negative 0.16292 plus or minus 1.76 times 0.03096. There we go. All right, so let's get what this is. So first I'm just going to, on my calculator, and sorry about the bad handwriting. There we go. Okay, so on my calculator right here, I'm just going to go and say 1.76, and I'll multiply that by 0.03096. There we go. It's 0.0545 rounded. 0.1629. I'm just going to round it to 4 decimals. That's fine. All right. So what we're going to do is we'll go ahead and say we have negative 1. We have a confidence interval, right? We're going to figure out, let's see, the low one is going to be negative 0.1629 minus 0.059, 0.05, I got to write better here, 0.0545. Okay, so it's negative 0.2174. The higher one is going to be the same thing. I'm just going to go and repeat this here, and I'm going to change that to, now it is plus, right? All right, and that gives me negative 0.1084. Okay, good enough. Okay, there we go. Okay, so we have it right there. Just make sure that you circle the actual confidence interval and the degrees of freedom, which, where the heck did I put it? Oh, I have it all the way up here. All right, so let's rewrite that. Oh, I just read the formula. Sorry about that. So the degrees of freedom is 16 minus 2, which is 14. There we go. All right, and that's all you need right there is the degrees of freedom and the confidence interval. And right here, T star, I already wrote down somewhere right here. It's already right there. Okay, so there you go. Confidence interval, degrees of freedom, T star. Let's go to conclude. Okay, we're going to say we are 90% confident that the interval from negative 0.2174 to negative 0.1084 captures the slope of the population regression line. Okay, so, or you could just even say, remember right here, what we're doing right here is it captures this guy. So I'm just going to repeat what I already said. Captures B sub 1. And that is the slope of the population regression line. And that is relating, remember right here, that's relating right here, y equals price. Sorry, x, right here, it's relating x equals miles driven to y equals price. Price of a for y equals price, and then right here of and we're talking about 4 used Ford F-150s. There we go. Okay, good enough right there. Okay, so anyway, it's not as bad as it seemed like in class right here. Difference, remember, is the degrees of freedom is n minus 2. Don't forget that. Okay, and remember for the do section, you just need the confidence interval, degrees of freedom, and T star. Everything else is there. All right, and so just make sure that you understand how to read these mini tab tables. All right, this is the, remember right here, this represents right here the slope right there. The one in yellow represents the y-intercept. And standard error of the slope is right to the next under the standard error column, remember, okay? We'll use the P and the T for the next of when we do a test for confidence interval. We only need these 3 right there. That was all we need. Okay, guys, have a good day.